All right, today we're going to look at ways you can find area of a triangle using trig and also a new formula. So how do you find area of a triangle? You've seen that before, probably since elementary school, that you want to take half the base times the height. If the base is known, definitely use it. If the height's not found though, then you'd want to make sure you draw that in, and it always needs to be drawn in perpendicular 90 degrees to the base. And then you'd want to solve that out. Well, we know how to do problems like this, especially if this is equilateral here, and this makes a 90-degree angle. That means it's got to split this bottom in half. And so one of these triangles, this would be 5. We got our right angle, 10. And also we know in equilateral triangles, all these angles would be 60, 60, and 60, making both of these 30. So on our triangle down here, this would be 60 and 30. Now we should be able to find that height out. You could do it one of two ways. You could use sine, cosine, and tangent to do this. So we could do that. Also, this is a 30, 60, 90, so we know if we take the short side and times by square root 3, that should be the length there too. So it's either 5 squared root of 3, or if you used trig, say we use this angle, we'd have our opposite side and our hypotenuse. So you could do sine 60 equals the height. I'm going to pretend I don't know what that is, over 10. So the height's going to be 10 sine 60. And you could use your calculator then to approximate that, and we could find it out. Just showing you, both of these end up being the same thing. If you do 5 square root 3, we get that. If you do 10 sine 60, you get the exact same thing. So either way, you get about 8.66 there for the height. And now I'll plug all that information into our area equation over here to find the area. So it'd be half of our base, which was 10, times our height, which is 8.66. And now put that in the calculator, and you can come up with the answer there of 43.30. So that would be, and if they give any type of units, it ends up being whatever the units are squared when you find the area. So there's our area there. Another way we're going to look at finding it is if you know all three sides of a triangle. You can calculate the area of that using a formula that's been around for over 2,000 years called Herons Formula. It's after the hero of Alexandria. So this guy was born just after the switch from BC to AD there, 10 AD. In Egypt, and he worked in applied mathematics and figured out a way to do this if you have all three sides. So we're going to look at that here today. And how this works, how the formula works is you are going to find what's called the semi-perimeter. And how you get that S value is add up all three sides and then take half of that amount. And when you find that amount, if you take it and multiply that amount times that amount and subtract all three sides from it, it ends up equaling the same area. So this is that same triangle we just said. I'm going to show you that it ends up working out here. So let's find our S value first. So S in this case would be half of all three sides added together. Well, they're all 10 here. So we're going to add 10 plus 10 plus 10 or get 30. Half of 30 is 15. And so that's our S, our semi-perimeter. So when finding area now, area is going to be the square root of our S value, so 15. And then we're going to take our S value minus each side. So 15 minus 10, another 15 minus 10, and another 15 minus 10, since all the sides are the same length here. So what we're going to do now is multiply all that together and take the square root of it. So it's going to end up being 15 times 5 times 5 times 5. If you put that all in your calculator, it's going to give you 1,875. And then if you take the square root of that, just going to show you that you do get the same answer. So if we put in here square root of 1,875, you can see we get that same answer of 43.301 that we got in the last one. And that was the area that we got before, and it should be the same if this formula works out. So units squared here. So that formula is another way, if you know all three sides, that you can find it. And the sides don't have to be the same length like they were there. They can be anything. Another way you can find it is what's called the trig area formula. It's basically what we did before with solving for that height. It just gives it in a particular way. So if you have in a triangle any side angle side, which you know an angle with both sides on either side of that angle, you can use this trig area formula. This is a equilateral triangle, so we know all the angles are 60. So if we got that 60 with both known sides here and here, we can use this trig area formula. So how you do it is you do 1/2 of the two sides around the angle, so 10 and 10, and then times it by the included angle, which here is 60. So if that gets put in the calculator, it should give us, again, that same amount, 0.5 times 10 times another 10 times sine of 60. And you can see, again, we get 43.301. Same answer we've gotten all three times here. So this, you can see, also works out. How does this trig area formula work? Let's just see. It's basically just doing what we did before to solve it here. So if you were to have one of these triangles and we're doing our half base times height in this problem, that we'd have to find out what that height would be right here. So that would be using our angle here, we'd have the opposite side and the hypotenuse. So we do sine of our angle equals our height, which is our opposite side, over a, which is that hypotenuse. If I multiply by a, that tells me the height here is a times sine of our angle. Now if I put that into the area equation right here, it'd be 1/2. Our base here is b, times our height, which our height is right here. And if everything's being multiplied here, so if I just rearrange this a little bit, and you can do that when things are multiplied because it doesn't matter what order you multiply something. Here's our trig angle formula. So this is, if there's one you don't really need to remember, it'd be this one, because it's basically just how you would solve for it if you find the height and then put it in. But if you know the equation, might go a little quicker. All right, so let's use this trig area formula to find out here. Here's our angle. We know both included sides, so our area would be 1/2 of 12 times 15 times sine of the included angle. Just pop this in your calculator now and you will get the answer. So if you put that in, it should give you about 57.851 units squared as our area. Really easy. Just make sure you're in degrees on your calculator. All right, find the area of triangle ABC given these sides. So this one, if you want to, you could sketch out quick a picture of what this looks like. We got A, B, and C, which means little side A is there, little side B is opposite of angle B, side C is opposite angle C. If you know all three sides, now we're using Herons formula. So find that semi-perimeter, that S, which is half of all three sides added up. So we want to add up all three sides here. If you add all those up, that's 30. Half of that is 15. Okay, so now we got our S value. So now to find the area, it's the square root of S minus all three sides again. So on this one, that's going to be 15, and then we do 15 minus 8. We do 15 minus 10 and 15 minus 12. We can simplify those pretty quick here, though, so that'd be 15 times 7 times 5 times 3. Now just put that in your calculator and you can figure out the area here. So on calculator, do square root of 15 times 7 times 5 times 3. Our answer, or our area, comes out to be about 39.686 units. All right, now everything we looked at so far was just triangles. They might start throwing other shapes at you, but pretty much most shapes can be split up into triangles, and if you can find the area of the smaller triangles, you should be able to find the area of the whole thing. So here we have some kind of quadrilateral. They want us to find what's the area of it. Well, I think if we split this and make this into triangles by drawing in this diagonal, we can do that. Let's find this blue triangle first. That one should be pretty quick. We got side, angle, side here. So if we use our trig area formula, we can get that one. That's half of 4 times 6 times sine of 70. So that just pop into your calculator and you should be able to find that one out. And if you put it in, it should come out to be about 11.276 for that area. That's not the overall area, that's just the area of the blue triangle. Now, if we add that to the area of this red triangle, we can get that. But how do we do this red one? We don't know that that opposite angle is the same. And we can't assume it. Definitely, it doesn't look like it, especially because all these sides are different. So what can we do to do that? Well, find out anything else you could figure out about this triangle. And I think what we can figure out is this middle length right here, the diagonal line. We should be able to find the length of that because we know enough information. We know at least 3 things from this blue triangle to find that out. So if we want to find this length, we don't have an opposite side angle combination, so we can't use law of sine. But I believe we can use law of cosine to do this. So if I want to find x squared there, it'd be the 2 other sides squared minus 2 times those same 2 sides times cosine of the opposite angle, which is cosine 70. So now let's use law of cosine to find that out. Put that in your calculator and solve. So we get 4 squared plus 6 squared minus 2 times those same 2 times cosine 70. All that value we're going to need to square root because it's x squared. So if we square root this, and I'm going to arrow up and copy and paste that, we can find out what that is. So it looks like that length ends up being about 5.965. Okay, so now that we know that middle length, we know all 3 sides of that red triangle. So it looks like we can use Herons formula to find that out. Or you could also, at this point, find the angle across from that, and you could use that to use the trig area formula again. Either one would be fine to do to get that. Let's use Herons formula. So if we're if we're doing that one here, we're going to have to find our S value first. So that's half of all three sides added together. So 3 plus 5 plus the one we just found. So let's put that in the calculator. We got 0.5 times 3 plus 5 plus 5.965. So there's our S value. It's about 6.983. Okay, so now to get the area of that, we're going to do the square root of that S value and then times the S value minus all the sides. So if I take that value minus 3, that's going to be 3.983. If I take that value minus 5, it's going to be 1.983. And then I need to take my last value here, which is the side we just found. So subtract these two values and get the last one. So if I subtract those, that's going to be 1.018. Now plug that in your calculator and you can get that area to come out. And I've already done that just to speed things up. It should come out to be about 7.493 for that area. Now, last thing we need to do, we're not finished yet, to get the area now of that whole thing. We want to add those two together. So total area would be the two areas we just found added up. And that should end up being 80.769 units squared. So there's our total area of that quadrilateral. All right, next one, find the area. So there's a shaded region on here. You've seen these before back in geometry. How do we find this one? There's some different ways we could go about doing this, but I think probably easiest way would be to go through and find the area of this equilateral triangle, this big one here. And that would give us the area of the whole thing. But if we then find the area of this isosceles triangle right here and subtract that from the area of the big triangle, we'd be left with the shaded region. Both triangles there, we know all three sides, so we could use Herons formula twice here. So for the big outside one, let's find that S value. So that would be half of all three sides added together. It'd be 12 for each, which is 12 plus 12 plus 12 is 36. Half of 36 is 18. So the area of that triangle is going to be square root of 18. And then 18 minus all the sides, well, 18 minus 12 is 6, so it'd be 6 times 6 times 6. If you plug that one in your calculator, again, I've already done this ahead of time just to speed things up, it should come out to be about 62.354 if you want to check it. Check it with your own calculator. All right, so we got that one. That's the area of the whole thing. Okay, what's the area of this one? Well, now we want to do that a second time with that other triangle. So this semi-perimeter is going to be half of the sides added up. So here it's 7 plus 7 plus 12. That adds up to 26, and half of 26 is 13. So this time our semi-perimeter is 13. So now our area would be the square root of that number, and then that number minus all the sides. 13 minus 7 is going to be 6. Get another 6, and then 13 minus 12 would be 1 for the last one. And so now multiply all that and take the square root, and that area should come out to be about 21.633. In this case, last time we added them together, but here, remember, it's kind of cut out of that shape, so we'd want to subtract them. So on this one, our total area, or actually I shouldn't, let's go shaded, because we're trying to find the shaded area. Shaded area would be 62.354 minus this other one. And you should get, if you do this one, about 40.721 units squared. So there's our area of our shaded region. The next one wants us to find area of a parallelogram. For this one, again, if we cut into triangles by going along the diagonal here, I think we can do that. And in this case, remember parallelograms, you got parallel sides, which is helpful here because if we got parallel sides, that means our angles would have to be the same. And if parallelograms, remember our opposite sides are the same. So we got the same thing going on here for both of them. So if we find the area of one and double it, that should be the area of the whole thing. And we can use our side angle side, so we can use that trig one to do this. So we got area is going to be 1/2 of our two sides here times sine of the included angle, 45. So go through and you can solve that, put it on the calculator, whatever you want to do. Should come out to be about 63.640. So that's the area of one triangle. So now total area, either add two of these together or double it, so it'd be 2 times the area we just got. And that should come out to be approximately 127.27 units squared. So if you can find quick ways of doing it like that one, go for it. All right, this one's similar to one we looked at already. You want to find the area of this kite. Why don't you pause the video and try this one. One thing you might want to consider is maybe just drawing that line in to help you. And I think you can kind of solve it like our shaded one we had before. So pause it and see what you come up with. All right, let's see how you did. This one is similar to the one we did before, except we weren't given this side here, but you can find it with law of cosines, because we got this side, and this angle here is 70. So if you solve for it, that side here comes out to be 9.177. Now we can use, since we got all three sides of the big triangle and all three sides of this cut out triangle, we can find both and subtract. So if you did Herons formula with the big one, the S value is half of all three sides, so 8, 8, and the one we just found. So there's our S value. Now take that S value minus the two sides. So if you minus 8 from both of them, you get this. If you take that 12.589 and minus the other side, you get this. Area of the whole triangle comes out to be about 30. Then we got to find the cutout one, so do the same thing with 6, 6 in the found value. And then that area is going to come out to be about 17.7. Subtract them, and then here is the area of that kite. There's some definite other ways you could do this one as well. Maybe a second way you could do it if you wanted to try a different way. Should come out to be the same thing. You could like cut this in half, making both of these 35 degrees, and you could find a bunch of stuff and do it that way too, where you find the area of one of these and then double it would also work. So there's some different ways to do that one. All right, the next one. Find the measures of the largest angle of a triangle with sides 30, 25, and 15. Here you definitely would want to draw out a triangle so you can kind of see it. So longest side here would be 30, shortest side's 15, and the other side's 25. which is the largest angle? Well, you got to know in triangles, the largest angle is going to be opposite the largest side. Largest side is here, so we're trying to find that angle located right there. How do you find the angle given three sides? You can't do law of sines, so we'd have to do law of cosine. So start with the opposite side. You get your other two sides squared minus 2 times those same two sides times cosine of the angle opposite, which we don't know, we're trying to find out. If we solved this, then you should get that angle. Start again, remember, by squaring it. So 30 times 30 would be 900. We can do this on our calculators. So go through and square both of those and add them together. That would be 850. We can multiply these together. So 2 times 15 is 30. 30 times 25 is going to give us 750. Cosine of our angle. Now to solve this, we can't, recall, you don't want to put those together. You can't subtract them and get 100 because it's being multiplied. We're going to have to minus 850 here. So that's now just 50. Don't forget the negative sign. Now we're going to have to divide by negative 750. So now we got cosine of our angles equal to, and I'm just going to leave it as this. And then final step, if we can't type in cosine of our angle, we got to move it to the other side and do inverse. So in our calculators, if we type this out, it should tell us what our angle is there. So go on your calculator, start by doing inverse cosine, and then type in negative 50 over 750, and we get our angle. So the largest angle in this ends up being, looks like about 93.823. Oops, sorry, 93.8 degrees. So there's our missing angle. All right, last one here. They want us to find the area of this purple shaded region, and it's the region in between those three circles. So we need to figure out what the area is of some of these little sectors, and then use some subtraction to find it out. Some things we know here. They give us the radius of these circles. So the radius of A here is 6. The radius of B is 4. So that's also 4. That's also 6. And same thing here. We got 5 and 5 from the center. So we know those, and that kind of forms a triangle. And then we would, if we can find the area of that triangle and also the area of those sectors, then we can do some subtraction and figure out the area of that purple shaded region. Let's start with the area of the triangle. So if we know all the sides, we can do that. This side right here is 10. This side here is 9. And this side here, 6 plus 5 is 11. So let's use our Herons formula to do that. We got to find our semi-perimeter first. So S would be half of all the sides added together, 9 plus 10 plus 11. That's going to add up to 30. Half of 30 is 15. So now let's find our area of that triangle. So it'd be square root of 15, and then 15 minus all the sides. So 15 minus 9 is 6. 15 minus 10 is 5. 15 minus 11 is 4. Put that in your calculator, and you can get the area of the triangle. It's going to be about 42.426. So that's the area of the triangle. Now what we're going to have to do is find what's the area of all those sectors. Well, recall, to find the area of a whole circle, a circle is, the area of the circle is pi r squared. If you want the area of just a portion of the circle, you want to take the angle out of the total angle and come up with that proportional value. So in a triangle, or sorry, in a circle, we know the angle, whatever the angle is going to be out of 360. So if we find that proportionate value times pi r squared, that would give us the area of the sector. So that's the little equation we're going to need. Well, we have the radius of each circle. What we don't have is the angle. So we're going to have to figure out what's the angle of all three circles here, like this angle, and this angle. And then once we know that, we can use our sectors, find our area of the sectors, and subtract it. So we'll do one of them just to kind of show you, and then we'll just, I'll have the answers for the other ones, and then we'll find the total. So let's say we wanted to find this sector right here. So what we're going to have to do is first find that angle. We can do that with law of cosine, since we know all the sides of that triangle. So we can, if I'm using A there, I want to find the side up. I'm going to find angle A using the side opposite, which right here is 9. So I got 9 squared equals my other two sides of the triangle squared, which is 10 squared plus 11 squared minus 2 times those same two sides, times cosine of the angle opposite, which is my angle A there. All right, so if I solve this out, I will now know that angle. So go through, we can square these, so 81. Here, if you square 10 squared and the other one, do the other one squared, so we got 100 plus 121 is going to be 221. Here you got 22 times 10, that's 220. Now remember, you got to subtract here. Don't put these two together. We got to minus this to the other side. Okay, now we want to divide by negative 220. Those two negative numbers will end up being positive, and then to solve for A, we're going to have to do cosine inverse of 140 over 220. So put that in your calculator, and you can do that. If you end up doing this one, you're going to get that the angle is about 50.479. So that would be angle A. Now, if you want to find the sector here, we're going to use that angle and use area of a circle. So the area of that sector then, the area of that sector is going to be our angle we just found over 360 times pi r squared, and the radius of that circle is 6, so pi times 6 squared. So if you put that in your calculator now, and do that, you're going to get that the area of that sector ends up being about 15.858. Okay, so now you would repeat that and find, we'd want to find the angle here, and then use it to find that sector. We would do it another time here, and find this angle, find the area of this sector, and then once we got them all, take the area of the triangle minus those three sectors, and that would be your final shaded region. If you want to go through and try the rest of that, I'll let you try it on your own, but you should get, if you do it right, that our shaded area in purple there does come out to be approximately 3.85 would be the area. If you want to continue and try the other ones and then subtract, that ends up being the answer. But you should have kind of the idea of how to do it now. All right, try some of those now on your own.